Let's examine a critical but often misunderstood distinction in ADAS work: the difference between a failed calibration and an improper, false positive or false negative calibration. ADAS calibration aligns a vehicle's cameras and radar sensors to ensure they function correctly. Accurate positioning is essential for proper perception of the road, as even small shifts can impact performance. Manufacturers specify targets, measurements, vehicle setups, and conditions for effective calibration. A failed calibration is straightforward. The calibration procedure does not complete. The scan tool reports errors or diagnostic trouble codes, and the affected ADAS feature remains disabled until the issue is corrected and the calibration is repeated. These failures are typically caused by clear issues such as incorrect target placement, environmental interference, or damaged or shifted sensor mounts. The failure is visible, documented, and prevents the system from operating. Let's now turn our attention to a more concerning situation: improper calibration. Improper calibration occurs when a routine reports success without meeting OEM tolerances, even with no diagnostic trouble codes. Tests show calibrations can pass despite targets being off-center, at incorrect heights or angles, on uneven surfaces, or in poor lighting conditions. In a study conducted at the Transportation Research Center, technicians intentionally violated manufacturer standards. The calibration was done outdoors on uneven ground and in direct sunlight. The vehicle also had an off-center steering wheel and a low fuel level. The poor calibration led to critical failures. Forward collision warning alerts were late due to misalignment. Pedestrian automatic emergency braking was delayed and highly variable. Stopping distances became inconsistent, reducing the safety margin. Lane departure warnings became asymmetrical, failing to trigger on one side or triggering late. In another study, Burke-Porter conducted a series of radar calibration tests, specifically looking for false positives when the sensor or targets are misaligned. The physical test used a radar-absorbing wall and corner reflectors, with some targets deliberately placed in intentional misalignment positions to challenge the radar's compensation software. The red triangle represents the OEM's specified position, the exact spot where the car manufacturer says the target should be for a perfect calibration. The graph tracks results from the Mosaic target positioning system, where green diamonds indicate successful system compensation and red X's mark failures caused by misalignment that led to incorrect radar readings. This testing determines the radar's tolerance levels and field of view, ensuring the vehicle reacts correctly to real-world driving scenarios despite minor sensor imperfections. In these situations, the system is effectively calibrated to the wrong reference frame. The sensors are taught incorrect spatial information. The ADAS system may appear functional, but its behavior is compromised. That's why controlled environments, strict adherence to OEM procedures, and proper documentation aren't optional. They're essential to restoring ADAS systems to true compliance and verified performance.